Hi guys, I hope you had a nice weekend. Today what we're going to start into is the section 3.4 on parallel and perpendicular lines. So the first part here wants you to put these two in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so for this first guy, just to review, I'm only probably going to do one of them. You would subtract 3x from each side. They are not like terms, so they do not combine. So I have negative 4y, don't lose that negative, equals negative 3x plus 12. And then to get y by itself, I will divide everything by negative 4. So at the end of the day, I have y equals, those two negatives cancel, so 3/4 x minus 3. Okay? So here you can see that the slope is 3/4. When it was in the standard form in the beginning, you couldn't see what that slope was. That's going to be important. Okay, so let's talk about parallel lines first. Okay, so it says graph each of the following lines on the same graph. Examine the equation of the lines to determine relationships between the lines. So let's say that y equals 1/2 x plus 2 and y equals 1/2 x minus 3. Okay, so remember to plot this. Your m is 1/2, your b is 2. So we start at our slope, or excuse me, at our y-intercept of 2, and then we count by our slope. We go up 1 over 2, up 1 over 2. Okay? If we do the same thing here, our m is 1/2, and our b is negative 3. So we start at our b, which is our y-intercept, negative 3, up 1 over 2, up 1 over 2. So you should notice that these two lines are parallel. Okay, so the relationship between the two lines is that their slopes are the same. Now, you need them to be in slope-intercept form, though, before you can determine that their slopes are the same. So keep that in mind. Okay, so in perpendicular lines here, so let's say that the first equation is y equals 2x plus 1, and let's make this one y equals negative 1/2 x plus 5. Okay, so let's plot these. So here my m is 2 and my b is 1. So my b, go up to 1 on the y-intercept, go up to, technically it's 2 over 1, so go up to right 1, up to right 1. Okay, this one, my m is a negative 1/2 and my b is 5. So go to your b of 5, and then we go down 1, right 2, down 1, right 2. Sorry, not the best connecting job there. So here, these are perpendicular, and perpendicular means that they intersect at a right angle. My gosh, I can't spell. Okay, the thing that you need to pay attention to here is that your slopes are opposite reciprocals, and I'll elaborate on that in 1 second. That's the key thing. So there's two parts to this. They need to be opposites and they need to be reciprocals. So when I say opposite, that means one's positive and one's negative. So for example, if I said 1/2, right, the opposite then, since that's positive, would be a negative, and then the reciprocal means whatever it is, you flip it. So if this fraction is 1 over 2, it becomes 2 over 1. So let's say I started with an m of 4. Let's actually say negative 4. The opposite would be a positive 4. Now you can do positive, or you can just not write the plus sign. Technically, this is 4 over 1, so the reciprocal of that would be 1 over 4. Okay, so they're opposites and they're reciprocals. Okay, so a little summary here. Parallel lines have the same slope. Perpendicular lines have opposite, so a sign change, and reciprocal. So flip it, slopes of each other. Okay? So if two lines, this is just a total side note, if two lines are perpendicular, the product of their slopes is a negative 1. So if you would take 2 times negative 1/2 and multiply them together, because they're perpendicular, you would just get negative 1. That's just a side note. Okay, so if the slope is a over b, the parallel slope would be a over b. The perpendicular slope would be negative b over a. So change the sign, and flip the fraction. So here, if my m is -2, the parallel slope is -2. The perpendicular, flip it to positive, and technically this is 2 over 1, so make it a positive 1 over 2. Parallel would be 2/3. Perpendicular would be -3/2. Right? If the slope is 0, the parallel slope would also be 0. The perpendicular slope, technically, if you want to make this like 0 over 1, if you flip that, it'd be 1 over 0, which is undefined. Can't divide by 0. Okay? Are the following lines parallel, perpendicular, or neither? So, if you look at this, your slope is 2, and here your slope is 2, so those are parallel. Okay, if you look at this one, your slope is 1/2. Here, your slope is -2. So this one's positive, this one's negative. It was 1 over 2, and technically they flipped it to 2 over 1, so that would be perpendicular. All right, now, this is important right here. Neither of these are solved for y. They're not in slope-intercept form, so you don't know their slope the way they are. So let's solve for y. So in this one, we would subtract the 3x over. So here my m is -3. In this one, we would add 6x over, and then we would divide everything by 2. So I get 3x plus 8. So here my m is 3. So here I have a slope of -3, and here I have a slope of 3. They're not the same, so they're not parallel. Now, they do flip signs. I go from negative to positive, but I don't flip the fraction, so they're not reciprocals, so this would be neither. Okay. I'm going to skip here to these last two examples. So here, we want to find the line parallel to this and that goes through this point. So I cannot be more clear. If I want it parallel, I want the same slope as this. That's the only reason I'm using this equation is to find the slope. So the slope of this is 2. So that's what I want my slope in my new equation to be. Once I find that slope, I no longer need this. I'm done with it. Cross it off. Now I have m equals 2 and I have the point 1,7. Okay, so we know y equals mx plus b. So let's fill in. That's my x and that's my y. So 7 equals 2 times 1 plus b. So 7 equals 2 plus b. If you subtract 2, b is 5. So my new equation is y equals 2x plus 5. I do not use that 8 for anything at all. Only thing I need that equation for is to pull out the 2, and then I'm done with it. So they want you to find a line that's parallel to this. Well, this is parallel to it, and it also has to go through this point. Find the line perpendicular to this that goes through this point. So here my slope is 2/3. So the perpendicular, this symbol right here means perpendicular slope. I would flip it, so it's negative, or excuse me, I would flip the sign, and then I would flip the fraction. So that's my new slope. Once I get that, I'm done with that. I have my slope, and I have this point 10,7. So y equals mx plus b. This is x, and this is y. So let's fill in. And you can use a calculator here to do this multiplication if you need. You're going to get -15. So add the 15 over, you get 22 for your b. So y equals -3/2 x plus 22. So if I were to graph this original and graph this on the same line, they would be perpendicular to each other. So on this next file, you're just doing the odds, right? You're doing a couple where they ask for parallel, 3 parallel, and then 3 perpendicular. So these 6 questions are what I did in those last 2 examples, right? Then there's a practice quiz. So the practice quiz has a couple where I want you to determine, are these parallel to each other? Circle them if they are, cross them out if they're not. Are these two perpendicular? These two. Circle if they are, cross them out if they aren't. Now here, this is what I did in those last 2 examples on the notes file, but then they want you to graph them both. So they want you to graph the original and graph the new line. So if I were you, I would graph the original first, pull out that slope, and then get rid of it. And then graph your final answer also on the same axes. So there's 4 examples here. I will have all these keys here as well, and then there's the graded assignment below all of that. Okay, I will have office hours on Tuesday for anybody who needs help with any of this. Please email me or send a remind message at any time if you have any questions. I hope you're well.